All right, we're going to carry on with our lesson dealing with equations. Right before the Christmas break, we started with two-step equations. And with two-step equations, you had to isolate the variable, solve for the variable using inverse operations. So let me take and just make a simple little two-step equation here. So let's say we have 2x plus 5 equals, let's just do a real simple one, 25. Now, what I don't want you doing is guessing and checking. I don't want you trying certain numbers and just seeing if it works out. For instance, I don't want you to say 2 times 4 is 8, 8 plus 5 is 13, 13 doesn't equal 25, so let's try another number. So I want you actually working through the process. We talked about the process as being taking care of the inverse operations of adding and subtracting first, then taking care of multiplying and dividing, and then checking our work. That's still going to hold true. So for instance, this two-step equation, we would take care of the plus 5. That's a plus 5 or a positive 5, so we have to put the inverse with it. So I would do minus 5 on this side, and then to balance it out, I would have to do the same thing on the other side of the equal sign. So when I subtract over here on the right side, that gives me 20. The two 5s, the positive 5, negative 5 cancel out, so all I do now is drop down that 2x, so that gives you 2x equals 20, and that is my first step. And if I follow through the steps, I have taken care of the addition and subtraction, so I move down to the second step, which is multiplying and dividing. So I look at the problem, I have 2x equals 20, 2x means multiplication, so the inverse of multiplication is division. So what I do is divide each side of the equal sign by the number with the variable. In this case, the 2 is the coefficient, so I divide each side by 2. These 2's cancel out, so that gives me x equals 20 divided by 2 is 10. So I have used that step, and my final step is to always check it. So what I would do here is I would take this 10 and I would substitute it in for the x, so that's 2 times x, so that means 2 times 10 plus 5. 2 times 10 is 20. 20 plus 5 is 25, so that works out. And I was able to check it in my head. Didn't have to really do much work, but a lot of students don't want to check their work, but even if you just do it in your head, it kind of helps out. So that leads us now into where we're going to start today, which is solving equations with variables on both sides. Now, a lot of students, it's taken them a while to get used to these lessons. We're going to be doing these lessons a lot. So I shouldn't have to tell you necessarily what you need to take notes on. I'm not going to always highlight things, but I am going to highlight things in this one just to kind of get you back on track. But always pause the video as needed. If you go through the video, that's a 15-minute video, and you're taking notes, it should take you somewhere probably about 20 to 30 minutes by the time you take notes and listen to what I have to say. So our topic today is we're continuing on with equations, but the focus is solving equations with variables on both sides. And then our essential equation is, how do I combine like terms to solve equations with variables on both sides? All right, when solving equations with variables on both sides, what we're going to do is look at the process that we go through. So let me go ahead and highlight this. And again, that's the topic. And here's our central question again. How do I solve how do I solve equations with variables on both sides? So sometimes you have expressions, sometimes you have equations, and sometimes both expressions in an equation can have variables. What that means is you're going to have an expression on the left side of the equal sign, and you're going to have an expression on the right side of the equal sign. And those two things put together with an equal sign form your equation. So to solve this type of equation, you need to bring all variables to one side of the equation. So I'm going to start highlighting here. When you have an equation with variables on both sides, that means you have like an x on the left side of the equal sign, and you also have an x on the right side of the equal sign. And sometimes you may have more than one x on both sides. And then you just have to go through the steps. So let's say we have this problem right here. 2x plus 6 equals negative 3x plus 1. Now, I want you to ignore what's on the right side over here for right now, okay? Because I'm going to work it over on this left-hand side and kind of show you the process that I want you to take. So if we have the equation 2x plus 6 equals negative 3x plus 1. Now, as you'll notice, you have your equal sign. On the left side of the equal sign, you have 2x plus 6. On the right side, you have negative 3x plus 1. So, first thing we want to do is we want to move one variable to the other side. Most students like to have the variable, the x, the y, whatever the variable is, on the left-hand side of the equal sign. So what I'm going to suggest you do is move everything to the left-hand side. Okay? So what we have to do, working and solving equations, always deals with inverse operations. So what we're going to use to move this negative 3x is the inverse. Okay? This is a negative 3x. What's the inverse of a negative 3? What's the opposite of a negative 3? It is a positive 3. So what I'm going to do here is I want to cancel out that negative 3x. So what I'm going to do is I'm going to do the inverse of it to move it to the other side. Just like we did with the two-step equations when we had to isolate the variable. So if I add something to one side of the equal sign, what do we do with equations? We do the same thing to the other side. So what I'm going to do is I'm going to add a 3x over here to the left-hand side. So I'm going to say plus 3x. All right, what happens to a negative 3x and a positive 3x? They're opposites, so they cancel out. So when those cancel out, that leaves that 1 on the right-hand side. 2x plus 3x, if you have 2 x's and I add 3 x's to it, combining like terms, we've already taken care of that this year, that gives us 5x. So I now have 5x plus 6 equals 1. And what we did is we kept everything the same by adding 3 to both sides or 3x to both sides. All right, so if you think about it, what I did is I moved the variable from one side to the other. So my first step now to solving an equation is move variable to the left side. And what I'm going to do here is I'm going to make that kind of small. So step number 1. Move the variable to the left side. Okay, I'm actually going to make this smaller so you can see the whole thing where I have it shaded. So the first step we're going to say is move the variable to the left side. Once we move the variable to the left side, we now have ourselves a two-step equation. So as we all know with two-step equation, second thing is we take care of addition and subtraction. All right, so second step is let's take care of addition and subtraction. I'm going to kind of move that there to give some room. So I have 5x plus 6 equals 1. We now take care of addition and subtraction. I have a plus 6. The inverse would be a negative 6 or a minus 6. I have to do the same thing to the other side. So that gives me 1 minus 6. This positive 6 and negative 6 cancel out. I drop down the 5x. 1 minus 6, that's a positive 1 and a negative 6. Different signs means we subtract. 6 minus 1 is 5. Take the sign of the bigger number. The 6 is bigger, so that means my answer is negative 5. All right, second step is to add and subtract. Now we go to the third step. Third step now is multiply or divide. And if you'll notice here, these are the same steps we use for two-step equations. The only difference now is I've added an additional step by moving the variable from one side to the other. And what's going to happen is we increase the difficulty of these equations. We're going to keep adding more and more steps. So now I want to look to make sure or to see if we have any multiplying or dividing. We have 5x equals negative 5. 5x means multiplication. The inverse of 5x, or the inverse of multiplication, is division. So I'm going to divide by this 5 right here. Okay, so I divide by 5 here. Do the same thing to balance it out over here. The two 5s cancel out. So that now leaves me negative 5 divided by 5, which gives you a negative 1. And then our fourth step, you always know the fourth step or the last step is to check your work. So we're going to say here, our last step is to check our work. So our steps, and if you will copy these down, our steps are going to be to move the variable to the left side. And the reason I say the left side is because that's what you're used to moving, or where you're used to having the variable. Second step goes back to what we did before Christmas. Look for addition or subtraction, then multiplication or division, and then finally check your work. And if I show you this over here, you see what I did here is I added a 3x. I added 3x, which gave us 5x plus 6 equals 1, which is the same thing I got over here when I worked it out. So let's just ignore this right-hand side for right now, and let's move on to the next page. All right, word problem this time. Suppose the temperature in your town is 21 degrees Fahrenheit and rising 1.5 degrees Fahrenheit every hour. Your friend lives far away and the temperature in his town is 28 degrees Fahrenheit and falling 2 degrees Fahrenheit every hour. In how many hours will the temperatures be equal? So the first thing we would have to do is obviously create our equation. All right, so what we're going to do is we know that we have two towns. One town is 21 degrees and it rises 1.5 degrees every hour. We know in the other town the temperature is 28 degrees and it falls 2 degrees every hour. And we want to know in how many hours will the temperatures be the same. So we know, since we're dealing with equations, we're going to have an equal sign. Okay. Now we're dealing with two different towns. So what I'm going to say here on the left-hand side, I'm going to call this your town. And on the other side, we're going to say your friend's town. Now, if you put it into words, sometimes that will make it a little bit easier to understand and how we can put it all together. Here, let me clean this part up right here. And make it so that we're working with everything the same, or on the same line. All right, so we know that we have your town and we have a friend's town. Our town, as we know, or your town, is 21 degrees, and the temperature rises 1.5 degrees every hour. So for every hour, it rises 1.5 degrees. So that means in 1 hour, it rises 1.5 degrees. Second hour, another 1.5. So I'm going to say 1.5x equals, and your friend's town is 28 degrees, and it falls. So when it falls, that's subtraction, and it falls 2 degrees every hour. So I'm going to say 2x, because 1 hour it falls 2 degrees, another hour 2 degrees. So if you know how many hours you have, you can figure out how many hours it has fallen. So I'm going to now go through the process here. Let me switch it back over to the pen, and I can now solve my equation. So our equation that we're going to work, we want to move the variable to the left side. That was our first step. So I'm going to take this variable, that minus 2x, and move it to the other side. So the way I do that is I use my inverse operation. That's a minus, so I'm going to say plus 2x. If I add 2x there, I've got to add 2x over here. And you'll notice I'm adding the x's with the x's, putting them with the x's, not with the other numbers. These two cancel out. I'm going to drop down this 28. 1.5x plus 2x gives you 3.5x. I'm going to drop down the 21. All right, so I've moved the variable to the left side. So now I'm going to take care of my adding and subtracting. So I have a plus 3.5, the inverse of that. Automatically, people are going to think subtraction, but am I trying to get rid of the 3.5 or the 21? We're trying to get rid of the 21. So if I look at that 21 as positive, so what I have to do is I have to put the inverse or negative 21. So I'm going to subtract 21 there, which means let's subtract 21 here. That cancels out. That leaves 3.5x equals 7. We now have 3.5x equals 7. We're now dealing with multiplication and division, which 3.5x is multiplication, so the inverse is division. So I divide each side by 3.5. So the 3.5x divided by 3.5, that cancels out. So that leaves x equals 7 divided by 3.5. If you need to go off to the side, divide 7 by 3.5, move the decimals and all that good stuff. You're going to see that you're going to get an answer of 2. So our answer here is x equals 2.